Hello, and welcome to the third part of this tutorial series on how to create your mobile controls and deploy your 2D platformer to an Android-based device. Okay, we'll be focusing on Android for this particular example. Now, let's have a look in the project panel. Okay, and if you look inside your sprites and UI mobile folder, you have these sprites, right? And also, if you do not have these sprites or you're starting from this tutorial, there's a link in the description. You can download the sprites from there, or you can use your own sprites. Okay, the objective is to be able to have some sort of GUI system. Now, in Unity, you have a graphical user interface system inbuilt. If you right click inside the hierarchy panel, there is UI, and it's got these couple of UI elements here. If you select button here, because we want a button, let's see what happens. Okay, you get something like this. Okay, you have this huge gigantic button and you have an even bigger rectangle kind of thing here. So well, what's going on? I mean, why are these buttons so huge, and where's the ground and stuff like that? Okay, don't worry, this is the canvas. This rectangle here, this is the canvas, and this is the main container inside which you place or arrange your buttons and sliders and stuff like that, the other graphical user interface elements. And this fan kind of thing, okay, these are anchor points. You see this anchor here, you see this XY, it's actually one of these. This corresponds to one of these. Okay, we can change it. For now, let's focus on this guy here, okay, the canvas, which is the master element, the main container inside which all the other GUI elements will go. But hey, where is the background? Don't worry, the background is right there. But the culprit here is one of the render modes. If you look here inside the inspector panel and the canvas component, the render mode currently is screen space overlay. So let's go ahead and fix it. Let's change this to screen space camera, and we're going to select the main camera. Okay, this is the same camera that's in our hierarchy panel right here. And hey, the guy just vanished. But where is the guy? Don't worry, it's still right there. Double click the main camera and your guy is right here. Now it's actually along the borders of the main camera. Okay, it's overlapping the main camera. And if you look at the game panel, you still cannot see the button because it's outside the bounds of the camera, right? So we're going to drag and drop this button by hitting this button here, bringing this button here, and like so. But hey, what's going on? Where is the button? The button is hidden behind the background and even behind the ground. Well, here's where your sorting layers are in action. If you remember, ordering layer 0 means that's the one which will be right at the back. So that's the reason the button is right at the back. Let's change this to 1 and see what happens. Still no good? Okay, if you notice, you have a little edge here. The button has actually come above the background, but it's still behind the ground. Because the ground here, let's have a look. This is the empty game object, the container, and these individual tiles or sprites, they have the order in layer 1. So for this button to come above the ground, this ordering layer is going to be 2. Okay, and there we go. We have the button. Now let's highlight the button here and let's drag it here. Okay, because we want our mobile UI to start appearing from here. Now, but we have this rectangular button. We don't want that, right? We want one of these images here. So how can we do that? Is it as simple as dragging and dropping them somewhere? Exactly, that's how we're going to do it. So you'd simply drag this guy here and drop it here in the source image. And there we go. But hey, this image is still rectangular. It doesn't look like this image. What can we do? It's very simple. All you need to do is set native size, and that's it. The image starts looking like this. But hey, this image still has this button text here. I don't want this text. How can I get rid of it? Okay, it's very simple. Every time you add a button GUI element, it comes with this text element, okay? You might want to delete it, and there we go. the button does not have the text element anymore. So, and also, now I introduce you to the canvas scaler script, okay? I'm not going to get into the more technical details about all the different properties. First, I want to show you exactly what we need to accomplish, and then I will describe these elements in detail. So, another important thing is the UI scale mode, okay? We want a game which will scale according to different resolutions, right? It should look the same on mobile devices or on tablets or on the PC and stuff like that. So how can we do that? We can do that using scale with screen size, okay? And since this game is working on 1024 by 600 reference resolutions, we're going to change it here. Change this to 600 and 1024, and that's it. And we're going to use screen match mode, match width or height, and we're going to specify 0.5. Okay, we want 0.5 is 50%. We want 50% of width to scale and 50% of height to scale. Okay, and now we're going to get back to the button here. We're going to increase its height and width to 100 and drag this guy down like so and place it somewhere here. Okay, this looks like the place to go. All right, let's rename this to button left, and make a copy of it and call it button right. Okay, and we're going to drag the button right like this, and we're going to change the image to this one. So button right, highlighted, drag and drop the image right here, and we have something like this. Okay, so far so good. Now we're going to create two more like this, and we're going to drag the two copies here like so, and we're going to quickly change the names to button jump. Okay, and we're going to call this guy button fire. Okay, later on, maybe when the player gets the ability to fire bullets. Okay, and let's change the sprite here to, let this be, okay, and let's change the sprites here. So this will be A, and this guy here can be B. Okay, and I also want to change the name of this guy here to button fire because it's the one on the right, and this guy button jump. Okay, all right, so far so good. So we have these buttons here. When you click on the play button, you would notice that your mobile UI is kind of set up. But in my experience, when you're playing games on a tablet or a mobile device and you have this kind of an arrangement, it's not convenient for the players. After a while, the thumbs begin to hurt. So I propose a better design. What we need to do is let's select the fire button, and we're going to move it a bit up like so. Okay, and this will make it a little more convenient for the player to play the game. Okay, so we have created the mobile interface, and now we're going to create the script which will allow us to control this character using the keyboard as well as these mobile buttons here. So let's exit the play mode. Okay, so let's go to the project panel, and in the assets folder, please click the scripts folder and right click inside here and create a C# script, and we'll call it player manager. Okay, double click this, and this is going to open the script in MonoDevelop. In case you've been following this tutorial from a previous video, you already might have a player manager, but I suggest that you delete that player manager script, and we're going to create it from scratch now. Okay, and like I like to do, I will rearrange these curly braces, and we're going to declare a couple of variables. First of all, let's declare a variable anim of type animator. Okay, we're going to store a reference of this animator component inside the anim, and we're going to get it here. So let's write anim equals get component, and then we want the animator, and like so. So So what this line of code does is we're storing the reference of the animator component, which is attached to the cat game object, okay, by using the get component command. And once we have a reference here, we can use it later on to switch between the animation states, okay? Now, we're going to declare another variable of type rigidbody2D, okay? And we'll call it RB, and we're going to use the same way of getting a reference. So we write RB equals get component rigidbody2D, okay, and we close the bracket, and like so we have a reference to the rigidbody2D component of the cat game object. And just to show you here, when you highlight the cat game object and you look inside the inspector panel, we have the rigidbody2D component, right? And we have the animator component, okay? And once we drag and drop this player manager script in here, like so, this script is going to be able to access these components using this line of code here, okay? First, we declare a particular variable of the type of the component you want to access, and then using this line of code here, this particular statement, this command, get component, and then specifying the name of the component you want, you can directly store a reference of any particular component, okay? Okay, now we're going to define a couple of public variables, okay? So we write public float speed x and public float jump speed y, okay? This will be the speed of the player or the cat game character. Okay, we're going to move it using the arrow keys and the mobile controls, and this will be the jumping speed in the y-axis. That means the vertical speed of the character. And we're going to define a couple of private variables. Now, if you do not mention private here, the standard C# programming convention is that you mention if the access modifier, okay, these are all access modifiers, public, private, these tell us the access levels of a particular variable or a particular class or a particular method, okay? So access modifiers. Now these access modifiers can be private, public, and protected, but in this case we're talking about public and private. So the standard C# coding convention is that you mention private or public just before the type of the variable. However, if you do not mention anything and you simply write the type and the variable name, so Unity is going to assign private, okay? That's the default. So if you see a variable inside any Unity script which does not have an access modifier, that is the private by default, okay? So here, this animator anim, this is a private variable. So just like this, we're going to declare another variable. We're going to call it bool, stands for boolean, facing right and jumping, okay? And we're going to declare a float variable called speed, okay? Now, right now, all of this is just a declaration. This will make sense once we start programming. Now, I want to make sure that you understand that the public variables, they are visible inside the inspector panel, and the private variables are hidden, okay? So this is the basic difference between public and a private variable. So you can have a look now. If you switch to the Unity editor like so, and we highlight the game object cat, and we look inside the player manager script, the speed x variable and jump speed y variables are exposed or are visible inside the inspector panel here, and you can assign values here which can be used in the rest of the script, but you would not see the facing right, jumping, or the speed variable here anywhere mentioned here. So this is the difference between a public and a private variable, okay? Now let's do some initialization here. You see this facing right, this variable bool, this will be used to determine which direction the player should be facing. So by default, the player is going to be facing right. So we're going to change this facing right to true. And now in the update method, we're going to invoke or call a method called movePlayer, and we're going to pass in the speed parameter or this private variable here, okay? But if you notice that this method name here is red in color. So why is it red? Okay, the reason is we haven't created the method. So Unity is complaining, or MonoDevelop is complaining that, hey, look, there's no method by the name movePlayer, so you need to fix that. So let's go ahead and fix it. Let's write in void movePlayer and pass in a float parameter called player speed. And that's it. Let's put in a comment, code for player movement. And let's come up here and put in a comment saying that, hey, this will handle the player movement. Okay, now player is going to move if we press a certain key or press a certain button, right? So let's handle the keys first. Okay, in this case, let's have a look at the game scene here, or this guy here. Okay, and there's a error because, okay, the name movePlayer does not exist in the current context. So we're going to take care of this error. For now, when you press the left arrow key, the player should move left, and the right arrow key should move the player to the right. Okay, so we're going to code it. So we write an if condition. If we're going to use the input class, input.getKeyDown. Okay, getKeyDown means when you're holding the key down, and you're going to pass in a key code. Okay, this is the technical way of representing a key code. Which code or which key? The left arrow, like so. Okay, so essentially this line of code here is saying that, hey, if the player is holding a key down, which is the left arrow, we're going to set the speed variable to negative speed x. Okay, now I'll explain in detail once we finish the entire script as to why we need to assign this negative speed x and how the speed is going to move the player. Okay, for now let's write some more code. Let's write if input.getKeyUp is key code dot left arrow. Okay, and we're going to assign 0 to the speed, means we don't want the player to move anymore. Okay, so we're going to write in a comment left player movement and close this. So we have a chunk of code handling the left player movement. We're going to copy it and put in a comment that now we're going to do the right player movement. And for moving the player right, we're going to assign the right arrow key. Okay, and this guy is going to be positive this time, and right arrow. Okay, now I'll explain why this is positive, why this is negative in just a few more lines of code. Okay, so we've got the left player movement and the right player movement, but hey, the player's going to jump also, right? So let's tackle that. Let's write an if condition, if input.getKeyDown here, and we're going to pass in a key code. This time it's going to be the up arrow. Okay, now how can we move the player up? We do that by using the reference to the rigid body 2D component here. Okay, we call rb.addForce. This is something new, and if you're kind of new to Unity, rb.addForce is going to add a force. Okay, and like it mentions here, this addForce method will take in a parameter of vector2 type. Okay, vector2, which will take in the x and a y parameter. So let's see what we can do with this. Let's write new vector2 and then pass in the x and y. Okay, so in here we need to write rb. Okay, and if you press the space bar, it's going to take the render buffer. We don't want that, so let's write rb and let's get rid of the IntelliSense and then write dot velocity. Well, MonoDevelop has its own quirks or its own shortcomings. This was one of them, but we have ways to work around them. So rb.velocity.x, okay, like so, and jump speed y. Okay, that's about it. And we're going to close the other bracket, and that's about it. So this is going to add a force in the vertical direction. We have not specified the force here, this rb.velocity.x. Now at this point, I want to introduce you to rb.velocity. Okay, when a body is moving, okay, it has a certain velocity, and velocity is speed in a particular direction. That's the difference between speed and velocity. So here, this rigid body 2D is attached to the game object, right? The player, the cat. So the cat is going to be moving with a certain speed, and speed in a particular direction is velocity. Okay, so, and if you see, velocity has a component of x and y. In 2 dimensions, we have only 2 parameters, x axis and the y axis. Okay, if this was 3 dimensions, it would have been x, y, and z. But here, since we're using a vector 2 is used for 2D games, or to find locations within a 2D space. So this velocity component, or this velocity, has just the x and y. So speed in the horizontal direction will be on the x-axis, right? So that's the reason we have mentioned rb.velocity.x. Okay, for up and down, it's the y component, okay, of vector 2. And this y component is being determined by the jump speed y. And what is this jump speed y? So you need to have a look here. Jump speed y is a public variable of type float, okay? So you have jump speed y, which you assigned, and that's the jump speed y here. So we're going to check now if the left arrow key is moving the player left and right or not. So let's hit the play button, and here's the player. We're going to hit the left arrow key and nothing's happening. It's not moving. Why did this happen? So let's press the play button and let's get back to our coding and see. Although we have done this part correctly, right? But if you notice, you have a move player speed here. Okay, this is the method which is going to move the player, but we have nothing in here. This is just the call to the method, and the actual method is right here. And if you notice, there's nothing here, and that's the reason the player was not moving. So let's move the player. Let's call rb.velocity is equal to new vector 3 this time, and we're going to pass in speed, comma, rb dot velocity dot y dot 0. 0 is for the z-axis, and we're not bothered with the z, so we're passing in 0. So that's about it. This is going to move the player, and we will check it just now. Alrighty, now before we hit the play button, let's have a look here in the player manager script. Okay, we have specified the speed x, or this will be the horizontal speed of the player. That's 6 units. However, the jump speed y, which is the jumping speed, is 0. This means when you press the up arrow key, the player's not going to jump. Okay, so you need to specify a number here. Let's put in 300 and see what happens. Let's hit the play button, and the up arrow is causing the player to jump, and the left and right keys are making the player move left and right. And here the player can jump and do all kind of things, okay, like so. But hey, did you notice something? The player just fell down. So why did that happen? It's very simple. When we exit the play mode and we look at the rigid body 2D component, okay, it's got these constraints. You know, in your case, the constraints might not be expanded, so you can click this arrow here, and this is going to show you these couple of options, these checkboxes. All you need to do is freeze the rotation, okay, and this will not allow the player to rotate. And we're going to check right now. So here the player hits one of these boxes like so, but it's not falling down. Okay, another thing, if you notice, when the player is moving left and right, or the player is jumping, there is no animation. So why is that so? We will just see. Let's exit the play mode. Okay, now let's look at the code here for the up arrow, and let's write jumping equals true. Okay, The moment the player presses the up arrow key, you want to change this Boolean variable to true. And we'll see why we're doing this. And now let's go ahead and add anim.setInteger and call our state variable and pass in the value 3, okay? Why did I assign state equals 3 when a player is going to jump? Let's see. In Unity, we have this animator panel or animator view, okay? And if you look at this arrangement here, okay, it might look complex, but it's not, don't worry. There's a parameter called state, and it's an integer parameter. It takes values from 0 to 3. Now, these are animation states, and if you notice, if the player is idle, there's an arrow going from idle to jumping, right? So let's highlight that arrow, this guy. And here, idle to jumping. This is the state change. And when does the state change happen? There is a particular condition. The condition is that the state parameter here should equals 3. And that's the reason we made this change. anim.setInteger in the state parameter and change the value to 3. The moment you do this, the animation state will change from idle to jumping, and this player will have a jumping animation. Okay. Let's see if this thing works. Let's go to the play mode, and we're going to hit the play button. There, the player is jumping now. But hey, when the player came down, it's still jumping. That shouldn't happen, right? The moment the player lands, the player should get back to the idle, right? Why is it not happening? Okay, here's the reason why. Let's exit the play mode. In here, you set the integer to 3, but there's no condition or there's no logic which will set it back to 0. Okay, the logic is simple. And I'm going to introduce you to collisions now. Let's have some space here, and let's type in void on collision, enter 2D. Let's type in collision, this guy 2D other, and in Unity, remember we talked about colliders, right? Those green boundaries, right? You can add a collider to a certain game object. Now, when two colliders or two game objects which have colliders, they collide, they decide to bump into one another, okay? A method is called, and that method is on collision enter 2D. And always remember, 2D is only for 2D games. If this were 3D, this would just have been on collision enter. Since we're working with 2D, this is going to be on collision enter 2D. And this method will take in a parameter of type collision 2D. Now this variable can be anything. It can be this, or it can be my blah blah blah, okay? You can name it to anything. I like to call it other, and we can quickly check here. If other.gameObject.tag equals ground, so what you need to do is you need to set jumping equals false, and you're going to switch the animation state like so back to 0. And that's about it. Okay, so what we just did here is the moment the player jumps here, we set the jumping Boolean variable to true, okay? And we add the force here, the player starts jumping, and we add the jumping animation. And when the player hits the ground, the on collision enter 2D method will be called. And this method will take in a collision 2D parameter, and we can get the tag of this particular collision 2D in this manner. Other.gameObject.tag equals ground. And what do you mean by a tag? So if you look at your Unity editor and you select the ground here, okay, this is a tag. Every game object can have a tag. Like in Facebook, you have tags. You can tag an image, right? So the same way you can tag your game objects using these predefined or your own user created tags. You can add a tag. So in this case, we had added a tag called ground. So we're checking that if the player has collided with any game object which has a tag called ground, so we need to set its animation from jumping back to the idle animation. So that's what we have done here. And since the player is not jumping anymore, we're going to set jumping equals to false. And that's about it. This will reset the animation. So let's have a look here real quick. Save it and get back to the play mode like so. Here's the player. We press the up arrow, the player jumps, and there we go. The moment the player hits the ground, the player is returned to the idle animation. Okay, now let's quickly add the left and right walking or running animations. Okay, so let's exit the play mode, and all of the animations for left and right player movement are going to be done in the move player method. Okay, now let's add an if condition. If player speed, okay, this particular parameter that this move player method is going to take in, if the speed is less than 0, okay, that means the player is moving in the negative direction, and like so, and the Boolean variable jumping is not true. Okay, so in a sense we're saying that if the player is actually moving in the left direction and is not jumping, okay, if this condition or player speed is greater than 0 and our player is not jumping, okay, when either of these two conditions is true, then we're going to do something. And what? We're going to set the anim.set integer, and we're going to change the value of the state variable to 2. Okay, 2 is the running state. So you want the player to start running the moment the player speed is in the negative direction and the player is not jumping, or the player speed is in the positive direction and the player is not jumping. Okay, at that point of time, you set the animation state to running. And just like so, we're going to check if player speed is equal to 0, means the player is not moving and the player is also not jumping. So at this point of time, we're going to change the anim to to 0. Okay, this is the idle animation. That means if the player is not jumping and the player is not moving, so set the animation to the idle state. And if the player is moving in the left or the right direction and the player is not jumping, so start showing the animation like so, the walking or the running animation. So we're going to save this, get back to Unity, and you see this update here. Every time you save a script, this small progress indicator, this tells you that whatever changes you had made, and Unity is actually refreshing the changes. So the moment this progress indicator stops, you can be sure that your changes have taken place. And that's when you can hit your play button and we're going to see what happens. We have the idle animation in the beginning. We hit the jump button or the up arrow, the player jumps. When the player comes back to the ground, the idle animation is playing. And when the player moves to the left, but the player is running. But when you hit the left arrow key, the player is doing a sort of moonwalk, right? Okay, it looks like the player is not turning and you don't want the player to do the moonwalk. So how can you fix this moonwalking thing? Well, here we need to add in a flip method. Void flip and code to flip the player direction. Now, before we write the code, I want to show you the manual process, how the flipping can be done manually, and then you'll have an understanding what you need to do in the code. So let's go to the Unity editor. Let's highlight the cat. Let's double click the cat so it zooms into the cat. Now, flipping is done by changing the scale here, okay? It's simple. If you add a negative sign here, the player flips to the left, and you remove the negative sign, the player turns right. Negative is left, without the negative is right. So that's all you need to do through scripting. You need to change the scale to negative to switch the player to the left direction, and remove the negative sign to switch the player to the right direction. Okay, So that was the manual process, and we can do it via scripting in this manner. Let's begin with an if statement. If speed of the player is greater than 0 and this player is not facing right, or the speed of the player, like so, is less than 0 and the player is facing right, okay, like so. So if any of these conditions is true, we're going to begin by chaining the Boolean variable facing right to its own negation. Now that sounded complex, but it's very simple. This Boolean variable here in the start method here, okay, was initialized to true, which means we assume that the player is facing right at the start of the scene or the game. And anytime you call the flip method, this particular statement will check if the player is actually moving, right? If the speed is greater than 0 or less than 0, it means either the player is moving in the left direction or the right direction, but the player is moving, okay? And these two conditions, okay, what you need to do is you need to negate the value stored inside facing right Boolean variable. Now this in simple terms means that if facing right was true, using this exclamation character, okay, this is called the negation symbol, you change the value to the opposite. Means if this is true, this will cause the value to be false, and if this is false, this will cause the value to be true. So this will flip the player logically. Now to cause the actual flipping, don't you think that when you access the transform.local scale and the x value and change the negative sign to positive and positive to negative, it should flip the player, right? Because that's what just happened. When we added a negative here, the player started looking in the left direction. Removing the negative caused the player to look in the right direction, right? So all you need to do is transform.local scale.x and change the sign here. Should that solve the purpose? Well, let's have a look. Let's call in transform.localScale.x and change its value, transform.localScale.x to negative. Well, I think this should solve the purpose, right? So let's have a look here. Let's hit the play button. Oops, it says all compiler errors must be fixed. So this does not really help. Let's go to console to see what's going on. No, this is a particular situation where Unity does not allow you to directly access the value, okay, of the local scale. This is a particular case or scenario, and Unity is offering a solution. It says, why don't you consider storing the value in a temporary variable? Okay, Unity, so we'll take your advice and we're going to do the same. We're going to remove this statement and we're going to declare a vector3, call it temp, and we're going to assign the local scale here to this vector3 variable. Okay, this is how Unity works. C# Unity works. You cannot access this value scale here directly. You need to have a workaround, and this is the way to do it. Like so, temp.x multiplied by -1. Okay, this line of code does the magic trick for us. So in a sense, if x was positive, multiplying it with -1 will change it to negative. And if this was negative, multiplying it with -1 will change this to positive, right? So that's how the flipping happens. But wait a minute. We still need to assign the temp back to the local scale like so. And this completes our flipping code, and we can quickly go and check it. And if you see this update is happening here, and the moment it stops, you know that everything is good to go, and we can hit the play button now. Alrighty, so we have the cat with all the crate and the background. Let's hit the left arrow. Yep, the cat is moving in the left and right direction with the correct animations. So that's cool. And we have the jump animation, and when the cat hits the ground, it is returned to the idle animation. So okay, it looks pretty good now. We will try to move through these boxes. The cat can do all sort of things now. Alright, now it's time for us to do the coding for the mobile controls, these buttons here, okay? This was the keyboard part of it. So let's exit the play mode. The logic is very simple. When you press a button, a method will be called, and that method will move the player to the right. If the left arrow button is pressed, this character will move to the left. So we can write methods to do that. First, we need to create public void walk left. This is a method, and in this method we will write speed is equal to minus speed x. Okay, and we'll copy this and paste it in here, and we'll write like so and remove the negative sign. Okay, these two methods will be assigned to the left button and the right button. Okay, and how we do that is, let's go back to Unity and let's rename this canvas to mobile UI. Okay, and this left button here. Okay, now let's look inside the inspector panel. It's got a button script with a couple of properties. Okay, I'm going to talk about these properties. First, I need to show you how to assign the method. So let's look right down here, on click. Okay, it says on click the list is empty. Well, here this is just one click, but we don't want that, right? We want the button to be held continuously. So we're going to add component, and we're going to write event trigger. Okay, and we're going to add a new event type. Don't worry if it sounds complicated, it's not. It's actually all the kind of interactions you can do, like moving the mouse, dragging, dropping, scrolling, selecting, you know, stuff like that. So in this case, we want pointer down. Okay, we want this event pointer down anytime the pointer is down, and we're going to add something to it. And what? Now, it's going to show you these options. So we need to drag a game object here, which has the player manager script. And what does the player manager script has? This is the player manager script. The script has these public methods, right? And because they have the access modifier public, means these methods can be accessed from anywhere, from outside of the script. We're going to drag this cat game object in here like so. Okay, and this will provide access to the player manager script here. And the player manager script has the walk left method. That's it. That's how you assign a particular method to a button. Okay, in this specific case, we're using pointer down. Pointer down is another event trigger. We added the trigger from add component. And similarly, we select the right button, go to add component, event trigger, and now let's add a new event. In this case, it's going to be on pointer down, and hit the plus button and drag and drop the cat game object like so. And in this no function, we're going to have access to player manager script attached to the cat game object, which has these two methods, right? These two public methods. And we'll select walk right, and that's it. That's it. You have assigned the walk right and walk left methods to these two buttons. So will it work? We'll just check in a few moments. Let's press the play button and walk right there. But hey, the player's not stopping. What just happened? We did the programming right? Okay, there's a small thing that you need to do. Although you have the on pointer down, but where's the on pointer up? Yeah? Okay, so that's the missing element. Okay, so we need to add another event, and that event is going to be on pointer up. Okay, and similarly, it's got the cat and player manager walk right, but we don't have any method which is going to stop them, right? So let's create that method. And this is going to be a public void stop moving. Okay, and simply we need to assign speed equals to 0, and we're going to get back to Unity, and in here the pointer up. Now the player manager is going to have stop moving. So that's it. Stop moving. Anytime the pointer or this button is released, the player will stop moving. Let's do the same here. Add new event, pointer up, and here player manager stop moving, and that's it. let's hit the play button. And now when we hit the right arrow, as long as we are holding it, the player is moving, but when we release it, the player stops moving. And the same thing is with the left arrow key. Okay, so this is how you program the left and right arrow key. But we still have this jump button. This is not working. So I'm pretty sure you now have a clue as to how this can be done, right? So we need to go back to monodevelop and create another public void jump method, and this will simply cause the player to jump. How the player jumps is by using rb.addForce, or you might just want to go up here in the update method where we wrote the code for jumping. Here, maybe let's just comment this code, jumping player code, and we can copy all of this from here and paste it in here. You can go back to the jump button here. Okay, and this time you need to press this button. We don't need to continuously cause the player to jump. And we need to select jump like so and hit the play button. Okay, let's press the A button. And yes, the cat is jumping now. Okay. And although the cat is continuously jumping like so, and it can go above the boundary, but then you can write a small Boolean variable to check if the cat can do a double jump or not. Okay, and it's very simple to implement. Anytime the cat is actually in contact with the collider of the ground, you can allow the cat to jump. Means you can set a Boolean variable can jump to true. But the moment you leave the collider, the can jump will be false and the cat will not be able to jump. But we'll leave that to another tutorial, maybe a platformer tutorial, because there are a lot of basics, like you might want to do particle effects, or you might want to create levels, and you might want to create enemies and stuff like that. And you might want to have this cat throw bullets, right? So it's going to be quite big, and this tutorial has already become quite big. So I want to stop it here, and I'm going to show you how to quickly deploy this on a mobile device. Now, to deploy this to your Android device, first you need to create an APK file. Okay, what you need to do is click on Unity right here and select Preferences. For Windows, it might be under File Preferences or Edit Preferences. And once you have this, select External Tools, and you need to download the Android SDK. Once you have downloaded the Android SDK, using the Browse button here, you need to specify the location of the SDK over here. Also, you need to make sure that you need to specify the home directory for your JDK installation. Okay, so you need to make sure that you have the Android SDK and the JDK downloaded. Once you have done this, please click on File and Build Settings, and you'll see a dialog box like this. Okay, and the first option is Scenes and Build. Okay, which of the scenes you want to include in your game build. So I've already added the gameplay.unity scene, but if you have not done so, make sure that you are in the scene gameplay.unity, and you can click Add Current, or you can go to Project and you can go to your Scenes folder, and you can drag and drop your scene in here like this. Okay, so I'm going to delete it by hitting Command Delete. So that's how you add a scene in the Scenes build. Then in the platform, which of these platforms are you targeting? Okay, since we're targeting Android, we will highlight Android and click on Switch Platform. You might have PC, Mac, or this selected, so you can select any of these platforms you want and click on Switch Platforms. Since this is Android, we're using Android. Okay, and let's leave these settings here as default, and let's click on Player Settings. In the Player Settings, here right on top, you need to specify a company name. Okay, so these are just default values that I've used. You need to specify a proper company name or your studio name before deploying this game to the Android marketplace or Google Play. And then you need to give a product name, the default icon. You can store your icon here inside the sprites folder. You can create a folder called icon and store your icon. And once you specify a default icon, that's about it. And if you notice, you have these tabs here, right? So this guy is selected by default. It says Android settings. Okay, this is for iPhone, this is for PC and Macs, this is for the web player, and this is for Tizen and WebGL and the Samsung TV settings. Well, for Android, now let's look at these settings from top. The resolution and presentation, you can change it from here. Default orientation, okay, it's going to be auto rotation, but I like to keep it landscape left for this game, so let it be landscape left. The status bar needs to be hidden. You don't want to see the battery status indicator, right, or the time showing up, so I have hidden it. And we're going to use a 32-bit display buffer. These are default values, so we're going to leave it like that. The icon, once you select a default icon here, you're going to have the icon automatically generated here, so you might want to just leave it like that. The splash image here, but since this is the free version of Unity, this option is not enabled. But for the pro versions, you're going to be able to use a splash screen. And in the other settings, now the other settings has a lot of options which are important. First one is identification, the bundle identifier. Okay, this is the package name. So change the package name here. Okay, in my case it's com.mystudio.mygame. You might want to name your game the way you want. For debugging purposes, you can use these values. The version, okay, this is the version that's going to appear in your Google Play console. Okay, when you open a Google Play console, let's take the example of Candy Crush, and you see this version here, this current version, right? This guy here. Okay, this is the same version that goes here. Okay, however, this guy, bundle version code, so it's going to be 1, 2, 3, 4. Okay, it's going to be a positive integer, and it cannot be a decimal. So this will be incremented by 1, 1, 2, 3, 4 in the ascending order, and this guy can be anything that you want. You can name it 0.0.0.1, like they have done, or like other popular publishers they do. So you can do this the way you want. And then the minimum API level. This is the minimum level of Android API that you want to support. So for this, the default is 2.3.1 gingerbread. So you can leave it here, or if you want to support the latest devices, you can go from 4.0 above, or according to your business requirements. Okay, now the configuration, this is the default mono 2x, and now the device filter. If you select this option, the file size is going to be much bigger. Okay, so this is completely your call. I like to use this, but feel free to use your own options. The only thing is, with this first option, your number of devices is going to be a lot more, but the file size is going to be huge. So and the install location is where your APK will be installed. So this is the default. It's going to prefer external. You have automatic and force internal. That's a good practice. Never try to force internal. Okay, the players might not like it. So prefer external. That's the default. Internet access is auto, write access is internal only. Now, this might be checked by default, Android TV compatibility, but since this is just a basic game, I unchecked this guy. And okay, this is an Android game, so you want to check this. And Android gamepad support means it works with the D-pad. Okay, supports gamepad, so this is the default. We're going to leave it like this. And for optimization, I suggest that you use .NET 2.0 subset. Okay, this will make your file size much smaller. Okay, and also this, I guess, is the default for Unity 5. And so you can leave the rest of these settings as they are. And when you click on publishing settings, there are two options: use existing key store or create a new key store. Now, if you select existing key store, you don't need to do anything. And when you build the APK, it's going to be built for debugging purposes, means you cannot upload it to the Google Play Store. To upload it to Google Play, you need to have a key store. And to do that, you need to click this, select a location, enter your password here, okay? And when you're creating the key store, you'll be able to specify a key. So you can select the key from this dialog box, enter the password, and that's about it. So when you go ahead and click build, it's going to build. So for our demonstration, I'm going to use an existing debug key store, okay? And this will show you this build Android dialog box. And in the save as text box, you can specify a file name. And I've provided the friendly name jumping cat. You can provide any name that you want, and you can specify an install location. So in this case, I'll leave it at default, and I'm going to save it. And since I already have a jumpingcat.apk, I'm going to replace it, and Unity is going to start building the whole APK for us. It's going to start assembling all the files, and doing its thing. And once this is complete, you're going to have an APK, which you can then deploy or install or move it to a folder on your Android device, and double click that APK, and it's going to ask you to install it. So go ahead and install it. And once it's installed, and here the build is successful, we have the APK file, okay? And so you can move that APK file now onto your Android device and install it, and then you're going to be able to play the game on your mobile Android device. And it's going to be able to jump across these crates here like so, and do its thing. So, well, I just wanted to share another thing with you. As long as this guy is standing here on the ground, right? The ground has a tag called ground. The player will be in the idle animation. But if you notice, you jump on a particular crate, the jumping animation is still on, okay? So I leave this as an exercise for you to figure out, why is this particular cat not returning to the idle animation, okay? And the clue is, it's got something to do with tags, okay? This ground here has the tag ground, so the cat returns to the idle animation. So why is the cat not returning to the idle animation on top of a particular crate? So the clue is, okay, what are the tags for these crates? Well, so with this particular exercise, I thank you for joining me in this lengthy tutorial, okay, and for all your patience. But I really hope that you've seen this process, and I shared the basics of how you can construct a particular level by dragging in backgrounds, creating grounds, these objects, the player, these mobile buttons, and how you can do your scripting, which is multi-platform. You can use your keyboard as well as the buttons. Then you've seen how to arrange your Unity GUI layout. So thank you so much for joining me in this tutorial. My name is Abel, and I welcome all your feedback and comments. And it'll be wonderful to hear some new ideas about tutorials which you feel you want to see, and I'll try my best to help you with that, okay? So now I end this tutorial, and I'll be creating some more tutorials. So till then, my name is Abel, and I wish you a wonderful, happy programming with Unity 5.